Hello and welcome to the second video of the Electrofun channel. This is the part 2 video for the project named LED controlling with the help of Arduino and Python. We will make a graphical user interface which will act like an application, and there will be two buttons named on and off to turn the LED on or off. So without delaying any further, let's move on to the project. In this project, the Arduino code will remain as it is. There will be no change, the same code as previous day. So the basic changes will be done in the Python. So let me move into the Python. So here is our Python code. Last day we have used this file ledtrigger.py that we have shown in part 1. So today I will make LED buttons with graphical user interface. So here is the code. First we have to import tkinter module, which is a wrapper class module which gives you the different functions like canvas and other things, like it gives you frames, canvas size, all the other things which you can implement to make a graphical user interface. And for details you can go and search for the documentation, official documentation of tkinter folder. And so I'm importing it as tk, and then I am importing serial and importing time. Serial and time module are the backbones of this project. So first I am defining the serial port. In the serial port I am taking a variable named Arduino which holds the serial module method serial that defines the serial port communication. For the communication we have to give the parameters as we have discussed already. It takes the COM port number, baud rate and timeout which is needed for communication to get established. So COM5 is the port for today also, and baud rate I am taking it the same as it was. You can take 9600 baud rate also because this project does not require fast communication, so that will be okay. So here I am taking a variable named decoded stat which will be needed later on. So currently I am assigning it to none. None is similar to null in Python. So then I am entering a loop, an infinite while loop. Then I am using try except system. In the try block I am holding a variable name status which holds whatever the Arduino, that is the serial port variable has read with the readline method. So Arduino.readline returns you whatever data is available at the serial port, and that is stored in the status variable. Then I am using decoded stat which we have already assigned into none. So decoded stat now reassigns to status.decode. So whatever value has been stored in status, that will be decoded with the help of UTF-8 standard, and decode is the method for that. If you don't pass any parameter specially mentioned to decode, then it will by default take the UTF-8 standard. So it will be decoded in UTF-8 standard, and that value will be recorded in decoded stat variable. And here I have used the print decoded stat statement for debugging purpose. And if this part is successful, if try block could execute successfully, then I will break that statement so I can come out of the loop and go further. So here that's why I am using the break statement. And except what exceptions can come here. The main exception that can come here is the Unicode decoding error, and it happens sometimes because whenever you read the status from the Arduino, or whenever you run the Python code with serial communication, every time the code gets executed, it resets the Arduino, and some garbage value sometimes is expected. And that's why when this kind of common garbage value regarding stuffs comes, the decoding fails, and that is a common issue with Arduino Python serial communication. So we can ignore that. It sometimes happens, sometimes doesn't, so it is not a matter. So I am giving a print statement, and then I am continuing the loop so that the loop gets reiterated. And now, talking outside the loop, I am taking another variable named string. It is almost like the previous day code up to this. So string variable holds whatever is decoded, and then it is stripped with Python strip command, and that has been explained the last day, and then it is for debugging purpose. Now we will define the functions for the buttons. Whenever we will press the button, it eventually has to call some function to execute what we want to do. So that's why we are defining the functions. First I'm defining the function for on button, that is known as on button method. And now what will happen if I press the on button, or rather I call the on function? It will turn the LED on. So to do so, we have to write b/h, because our Arduino code has uh, whenever the Arduino code, here we have defined that whenever the character in the serial communication port is capital H, then we will write the LED high, and if it is low, when it is capital L, we will write the LED low. So to do so, we have to send the byte formats of this capital H, and for that we are using B prefix. All these things are mentioned in the part 1 video. If you don't have seen it yet, please go and watch. You will find it in the I button. And then as usual, a time dot sleep of 1 second, 1 second waiting time to Arduino, to let the Arduino do its stuff whatever we are giving as command. And then I will configure the buttons. B1 is a command button class that has been discussed later. So wait for the right moment. I will come to this point later. And similarly, the definition of off button, here we will write the Arduino B prefix of L, that will turn the LED off, and as usual another 1 second sleep time. Now this part is essential. Take enter app initialization, because we are actually developing a GUI app with the help of take enter. So first we have to initialize all the parameters. So first I am taking a root variable. That root variable will be my GUI window that I am calling as root, or you can say root is my basic, the very main part of the GUI interface. So root is that part, and then I am calling the tk function from the module small tk, that is the take enter module, and that will give root all the facilities of the Tkinter window. You can go and check the documentation for better understanding. And now I'm calling the root.geometry function or method. This method will initialize the thing. When you run this Python code, the GUI window will open. So what will be the size of the GUI window? That is defined here. So I'm using a 300 by 300 ratio size of the window. So whenever the code will be executed, it will open, or it will create a 300 by 300 window. Then I'm giving the title for the window with the root.title method, and that I'm passing as button controller, because we are actually controlling buttons with it. Or rather, you can give any name of your choice, whatever you are doing. And then I am taking a variable of canvas named. It will hold the canvas. Canvas means, in real life scenario, what is a canvas? Where we can do our graphical stuffs or artistic stuffs. That is my canvas now. So here the canvas will be similar. So you have a window, and in that window will contain the canvas. In the canvas, all the graphical works that we will do will be there in the canvas, and the canvas will be contained inside the window. So it is like a set concept. If window is a universal set, then canvas is a subset of it, and canvas set is not equals to window set, because canvas will not be as big as the window may contain many things, and canvas is one of them. So canvas is will be lesser than the size of the window. So here I am using the canvas tk.canvas method, and canvas method takes a self class. That's why I am passing the root, because the canvas will be of the root class. I mean, root will have the access to the canvas. So I am sending the self class to the canvas, and my self class is here root. itself. So I am defining the width of my canvas to be 50 pixel and height of my canvas to be 50 pixel as well. And then I will canvas.pack. So canvas.pack is a function or method which packs whatever the components you have defined. You have defined a canvas of size with of the class root, and with the width and height of 50 is to 50, and all these things have to be packed inside canvas. So all these components are being packed with the pack method with the canvas. Okay, so now coming to the button part. So that's why I have skipped what is b1 and b2 in that part. So now it is time to discuss those things. So first I'm taking a b1 variable which will take the method tk.button method, which also takes a similar class, because this class is needed. Because why you are doing this stuff, for whom you are doing this canvas or buttons, you are doing this for the root class, because root is your window. That's why root class is passed in each of these case, for the canvas and for the button. And then whatever the button will hold as text, you have to give here and as text. So it is on button, I'm doing b1 for on button, so I'm giving the text on. And command is the function you have to pass, which function will be executed as a command when you press the button, that you have to give here. So my function for on button is on button, and that's why my command will be on button. It is written in camel case. And then these components, these are the components of my button one, that is my on button. So you have to pack this into the b1. So I'm packing it here. And b1 dot flash, flashing is like uh, you have done all the things, you have packed and flashed it. I mean, the this this actually resets the thing and makes it ready for use. So it is like that. Whenever you write a code for your processor or IC, or microprocessor rather I should say, so you flash the code into the processor, right? You upload the code and flash it so that the code will be ready to be executed by the processor. This is similar. You have packed the whole the thing and you have defined all the connect functions methods. Now you have to flash it so that it can be used by the button. So think the button as a processor. You have defined the and the components like these are the raw codes for the button or the processor. Then packing it means it is equivalent to uploading the codes to the processor and then flashing it. So you can think like that, it will be easier to understand. And similar case for b2, that is for my off button, their text will be off and command will be off button, that is my off button function, and then flash again. So these stuffs are commented out because these are something else I was trying to do. And so what I wanted to do, if you press the on button, press the off button, up to this code will do fine. If you do whatever the code up to written up to this, if you execute that, you can turn on the LED on and LED off also. But you can't understand without looking at the LED whether your button has done its work properly or not. You have to look for the LED or look for the hardware every time to see whether your button has been turned on or whether your button has been turned off or not. So I wanted to do something, a color change type of function, that if my button gets turned on, then my on button will be turned into green color, and if my button off button works properly and the LED gets turned off, then the off button will turn into red color. So to do so, in the on function, after writing the bh and giving the sleep, I'm reconfiguring the button. Configure is a method where you override the things, override whatever has been defined earlier. You are overwriting that. So BG stands for background color. I am reconfiguring the on button first. So I have to change the background color to green. So this is a hexa code for green color. You can find it online from any color picker site. This color will give you a mean green color. And the foreground FG stands for foreground. This foreground color is the text color of the button. What will be the text color of the button? So I am keeping it black because it suits best with the green color in the background. And I am configuring the off button as it is, because when the uh, button will turn on the LED, the off button will remain as it is. So its background will remain white and the foreground will remain black. And for the off button, reverse will be the case. Then on button will be remain as it is, white with background and black in foreground. But the off button will change its color to red in the background, and foreground color will remain black. So this is a bit modification, improvisation in presentation. And then this is the main thing, UI loop, user interface loop. That is, I am calling the whole class, whole window as a loop, because when we are running a GUI, the GUI remains on in your screen until you close it. So that is done by a loop procedure. The loop calls it time by time to remain on until you give the close window command. So that's why I'm calling, and this is essentially, you can think like that, it is the main function for the Tkinter GUI interface. So you have to call it from the root.main loop, because root is your window and you are calling the main function of it to run and execute the window with the main loop function. So this is up to this is the code. So it's time to upload the code to the Arduino. First I have to upload the Arduino code to the Arduino. So here is my Arduino code, and my COM port is COM5 already set. Arduino Uno is my board. So let me upload this. So my Arduino code is uploaded successfully. Now move on to the Python code. So here is my Python code. So it's time to run the Python code. So this is your window. So this window, the gray portion is of size 30 is to 30, 300 by 300 that we have mentioned here. 300 by 300 is the geometry. So this is the geometry, which is actually the size of the window, and it is the label named button controller. So now I'm going to turn the LED on with the on button. So my LED is turned on. As you can see, it has been changed in its color to green, and so my LED is on now. And if I use the off button, it will turn the LED off. Yeah, the LED is turned off and it has changed its color into red. So again I'm turning it on, the LED gets on. I'm turning it off, LED has been turned off and the color has changed. So this is what the basic GUI interface of this Python function, with the help of Python function and controlling the LED with the help of Arduino. So you can also implement this thing in your home on your own, and let me know how you implemented this. You can also do one more thing as a project, that you can take two LEDs, modify the Arduino code to turn on and off two LEDs, control two LEDs, and in Python, rather doing it for the single LED, you can take two LED buttons, for the one button to turn on the LED, another button to turn off the LED. And you can do one more thing. When you are dealing with more than one LEDs, you can keep only one button for individual LEDs, and whenever you turn the LED, press the button for a particular LED, it will turn on the corresponding LED. But if it is already on, that button, pressing that button again will turn the LED off. So you will not need to create two buttons for every LED. So it will act like, actually like a physical push button. So you can do that, and whatever you do and however you have felt with this video, you can feel free and let us know in the comment section below. Comment us how you felt about the video, what you learned from the video, and what we can improve. And also comment how you done this project at your home. If you have better ideas, suggest us. If you have better ideas to improve our video qualities, also suggest us, and tell me whether this video helped you or not. And if you like the video, please share it with your friends, relatives, teachers, with everyone, and make them to subscribe this channel. And also you guys, please subscribe our channel and share the video, give us a like. And also all the code and all the description part will be uploaded in the instructable profile of our, and the link will be provided in the description box below. So that's all. Thanks for watching. Thanks for being with us. Keep liking us, keep sharing us, keep commenting, keep subscribing. Thank you.